All right. Now let's understand the evaluation of VMware Tanzu Kubernetes. Because if you directly start learning VKS in VCF 9 without understanding this history, definitely you'll get confused. We will see so many names like PKS, TKG, TKGA, TKGS, supervisor, VKS, and you may think all these are completely different Kubernetes products. Actually, that is not the case here. VMware's Kubernetes platform has been evolving continuously for several years. So let's start from 2017 and understand how we reached the current VCF 9 Kubernetes architecture. In 2017, we had something called Pivotal Container Service or PKS. At that time, VMware and Pivotal introduced PKS as an enterprise Kubernetes platform. The main objective was very simple. Customers wanted to run Kubernetes in production, but deploying Kubernetes cluster, managing them, upgrading them, and integrating networking and container registries were not easy during that time in 2017. So PKS provided an enterprise Kubernetes solution by combining multiple technologies. If you look at the screenshot, you can see VMware, with the Pivotal, then you can see Kubernetes, BOSS, then NSX, Harbor. All these are combined together, and then they provided this Pivotal container service. So first let's try to understand why did customer need PKS in 2017. So there could be a reason, right? That's why VMware introduced this PKS product in the market, right? Let's try to understand that. So why did customer need PKS in 2017? Why could not customer simply download Kubernetes, create some virtual machine, then install Kubernetes, then create the control plane and the worker nodes and start deploying applications on it? Technically, customers can do that. And even today, we can manually build a Kubernetes cluster in the same way. But creating the Kubernetes cluster was never the biggest challenge for enterprise customers. The real challenge started after the cluster went into production. Let's take a production scenario, whereas we are running a banking application or an e-commerce platform or some other business critical application on the Kubernetes. In the beginning, maybe we have only 2 or 3 Kubernetes cluster, so we can manage everything manually. But slowly, when the customer environment grows, we have 50 clusters or 100 clusters or maybe even 500 Kubernetes clusters running across many data centers. So at that time, I need a consistent way to deploy these clusters, maintain them, then patch the operating system, upgrade Kubernetes versions, replace failed control plane and worker nodes, then manage the networking of the containers, then providing load balancer services for applications running inside it, then implement security policies, then manage container images and make sure the Kubernetes control plane is protected and recoverable. Now, just imagine one worker node fails in the middle of the night. Okay, so at that time period, who is going to detect that failure and who is going to recreate the virtual machine and how you are going to configure the operating system, then install the required Kubernetes components and bring that node back into the cluster? That's a challenging thing, right? Or just imagine like we have 100 Kubernetes cluster and a new Kubernetes version is released, and how I am going to manually upgrade every cluster one by one. What happens if the upgrade fails halfway through? How we are going to recover the cluster without impacting the applications running in production? Then one more thing is networking was another major challenge during that time. Kubernetes can provide container orchestration, but enterprise customers still needed production grade networking, right? Like how the pods are going to communicate, how applications running inside Kubernetes be accessed by users outside the cluster, who is going to provide a load balancing and network security and isolation between different applications and a different Kubernetes cluster. The same challenge existed with container images also, because developers were building application images, but where those images are going to be stored? Are we going to allow every production cluster to download container images directly from a public registry? No, that is not possible in production, right? Because the enterprise customer need a private container registry where they could securely store, scan, control, and manage their application images. So this was the actual problem customers were facing in 2017. So Kubernetes itself was available and customers could deploy Kubernetes cluster. But operating Kubernetes reliably at the enterprise was extremely difficult. Customers did not want to build their own automation platform or lifecycle management system, network integration, container registry, and then monitoring mechanism and recovery procedure around Kubernetes. So that is exactly where PKS came into the picture. VMware and Pivotal took Kubernetes as the container orchestration platform, and they used BOSS for deployment and lifecycle management, integrated with NSX for enterprise networking, and used Harbor as the enterprise container registry. So instead of customers building and integrating all these capabilities themselves, PKS provided them together as a supported enterprise Kubernetes platform. So the important point here is PKS was not introduced because customers could not install Kubernetes. PKS was introduced because installing Kubernetes was a easy part, but running in the production, then managing, upgrading, networking, securing, and recovering Kubernetes cluster during failure in production was a real challenge. And that was the problem that PKS was designed to solve in the production support. I hope you might get an idea like why did customer need this PKS in 2017. Let's move to the next slide.